Welcome! Today we're going to prove an important integral formula. The integral of 1 over the square root of 1 minus x squared dx equals negative arc cosine of x plus c. Let's approach this proof step by step. First, let's recall something important. The derivative of arc cosine x is negative 1 over square root of 1 minus x squared. This relationship gives us a hint about our integral. To prove this integral, we'll use trigonometric substitution. Let x equal cosine theta. This means dx equals negative sine theta d theta. Now, let's visualize this substitution with a unit circle. On the unit circle, cosine theta gives us the x-coordinate, and sine theta gives us the y-coordinate. For any point on the circle, we can see that sine squared theta plus cosine squared theta equals 1. This means that sine theta equals the square root of 1 minus cosine squared theta. And since x equals cosine theta, sine theta equals square root of 1 minus x squared. Now, let's substitute these into our integral. The integral becomes 1 over square root of 1 minus x squared times dx. Substituting dx equals negative sine theta d theta, and the denominator becomes sine theta. The sine theta terms cancel out, giving us negative integral d theta. This integrates to negative theta plus c. Since x equals cosine theta, theta equals arc cosine x, giving us our final result, negative arc cosine x plus c. To verify this is correct, we can take the derivative of our answer and see that we get back to our original integrand. This proves that our integration formula is correct.